Hello, I am Soyansu and I will tell you about the chapter Quadrilateral. So, what is the basic of geometry? So, what is the basic of geometry? You can see here 0D, 1D and 2D. They are they are 3D also, but in this chapter we are learning about quadrilaterals. So, I will go till 2D only. Okay, so there is points in a 0D figure, line segment, line and ray are 1D figure, and open and closed figures are 2D figures. Okay, so we will learn about what are open figures and what are closed figures. So first we will go to 0D. So what a point is a 0D? Okay, we have learned in this flow chart that point is a 0D. So point is a 0D geometrical shape with no dimension at all. It is like a dot. It is like a dot. You can see here. It is like a dot, like this, in this red dot. Okay, this dot. There is no specific name of dot. So we give it name ourselves. We can give it a name called letter. Any name a letter like A or B or this point C. Okay. So now I will go to the next page. So what is 1D figures? What are 1D figures? There are three types of 1D figures: line segment and ray. So what are 1D figures? 1D figures are the figures that have only one dimension. 0D has 0 dimensions, 1D has 1 dimension, 2D has 2 dimensions and 3D has 3 dimensions. Okay. So 0D means 0 dimensions, 1D means 1 dimensions, 3D means 3 dimensions and 2D means 2 dimensions. So there are three types of 1D figures, that are line segment and rays. Okay, so line is a figure that extends from both sides and had no end points. Its length could not be calculated. It goes throughout the universe. We cannot calculate its length or its ending points. But how can we draw line in the paper? Because it extends for forever. How can we draw it? So we draw a line segment. Wait a minute. We draw a line segment. We draw a line using arrow marks. Okay, or we can write this using if we can point here A and B. Its name will be A and B, but it has no endpoints. Okay, and we can show it with the help of arrow marks. We will write this line as A, B. Okay, we will write it like this and we will draw it like this. And then comes line segment. Has 2 endpoints and had no specific length. Okay, line segment had 2 endpoints and had a specific length. Okay, it has 2 endpoints. We can say it A and B. Okay, and then comes A, B. We will write it like this. Okay, and it will be drawn like this. Okay, it has a specific length, like it is suppose of 2 centimeter, 5 centimeter, 6 centimeter. Okay, then okay, so line segment. So what are lines made up of? When many points extend. Okay, so many points like this come together, we have a line segment. And when lines and when we extend this line segment from both the ends, we got a line. Okay, so now we will learn about ray. Ray has one endpoint and the other side extends forever. This also had no specific length. Example of ray is in light. Okay, so ray is drawn like this. It only one point is going forever and other is still at one place. Okay, also give this a name AB, and we write AB with the help of arrow mark also. Okay, AB, it depends how to write. If the figure in the figure, the arrow is here or the arrow is here. If the arrow is here, we will write with the arrow here. Like if the arrow is here, the ray is like this, AB. So we will write it like this. But if it is the point goes forever in this direction, then it is we write this like this. In this side we give an arrow mark. So if we have an endpoint from one side, okay, and continue forming points together without endlessly from one side, it is called ray. Okay, it is called ray. So now comes 2D. 2D figures have two dimensions, that are length and breadth. Okay, so we have learned that 0D had 0 dimensions, 1D had 1 dimension, and 2D had only 2 dimensions. 2D figures have two dimensions, that are length and breadth. They can be a curve or a non-curve. Examples of curves are circle, semicircle, etc. Non-curves are made up of line, segment. Some example of non-curves are quadrilaterals, triangles, and pentagon, etc. Okay, so 2D figures are have two dimensions. We have learned that 1D has only one dimension and 2D has two dimensions. They can be a curve or non-curve. Curve is like circle. This is a circle. This is a curve. Semicircle. This is also a curve. But triangles, pentagons, all these are non-curves because they are made up of pure line segments. Okay, pure line segments. Line segments do not have any endpoints. Remember that. So this chapter, which is upon quadrilateral, is also a 2D figure. So what are curves? Curves are 2D figures that are not made up of line segment. There are many examples of curves. Curves are of two types. They are closed curves and open curves. Closed curves. Closed curves are curves that are fully closed. There is no open space in their boundary. Example circle. You can see here. Wait a second. You can see in this figure that this is fully bounded. There is no open space from here. If there was an open space, then this wouldn't be a closed curve. Non-curve. Non-curve are the two figures that are made up of line segments. Polygons are non-curves. All polygons are non-curves. Okay. Non-curves are made up of line segments, but curves are not made up of line segments. Polygons. Polygons are some 2D closed curves with some characteristics that are closed figure made up of straight line segment, should contain more than two line segment. Some examples of polygons are triangle, rectangle, squares, etc. Okay, so a polygon is a figure that is closed, that is made up of straight line segments and should contain more than two line segments. Why more than two line segments? 3 and 3 more than 3 line segments. Why? Because more than 2 or 3 and 3 then more than 3 line segments. So why do we need more than 2 line segments? Because if we draw 2 line segments like this, then it wouldn't join. Okay, but it should be closed. So we need a third line segment to join them. So minimum line segments that we need to make a polygon are 3 line segments. This is a flowchart of polygons. So first come triangles, then comes quadrilaterals, then comes pentagon, then come hexagon, then come heptagon, then come octagon, then come nonagon, and then decagon. Okay, so we will learn about from triangle. Triangle had 3 line segments and it looks like this. Quadrilateral had 4 line segments and it looks like this. Pentagon had 5 line segments and it looks like this. hexagon had 6 line segments and wait a second. Hexagon had 6 line segments, heptagon had 7 line segments, octagon had 8 line segments, nonagon had 9 line segments, decagon had 10 line segments, and then comes there are many figures, and it goes till it becomes a circle, till it becomes a whole circle. And what about 11? For 11 we tell it 11 gone. For 12 we call it 12 gone. For 13 we call it 13 gone. Okay, that's why I have written here n gone, because n is a number, that is n is equal to 11, n is equal to 12, n is equal to 13, and n that is 11 gone, 12 gone, 13 gone. Okay, so this goes like this. Okay, then come diagonals. What are diagonals? Okay, what do you know about diagonals? Diagonals are line segment. Okay, they are line segments that join two opposite vertices of polygons, not triangle. Triangle do not have any diagonals, but quadrilaterals and figures more than 4 line segments and more than 4 line segments have diagonals. Like if we say quadrilaterals, they are made up of 4 line segments and they have diagonals. You can see here, this is a diagonal and this is a diagonal. There are 2 diagonals. If we say about pentagons that have 5 line segments, they also have diagonals. They are this, like this, like this, like this. Okay, so they are diagonals. Okay, so every polygon had diagonals except triangle. Okay, then come types of polygon on the basis of diagonals. Okay, on the basis of diagonals comes the types of polygons. Concave and concave polygons are polygon whose at least one diagonal is in the exterior of the polygon. You can see here the one diagonal which connect the wait a second, sorry, wait a second, sorry. Okay, so one line segment that joins these 2 points is outside this polygon. Okay, and these 4 diagonals which connect these 4 sides are also outside this polygon. So when the diagonals are outside the polygons, we call it concave polygon, and when the diagonals are inside the polygons, like you can see here, no diagonals are outside the polygons. Here also no diagonals are outside the polygon. So these are called convex polygons. When the diagonals are outside the polygons, the figure is called concave polygon, and when the diagonals are inside the polygon, it is called convex polygon. Okay, I hope you understood still here. Then comes types of polygons on the basis of sides. Regular polygons and irregular polygons. In regular polygons, all the sides of the polygons are equal. Example: square, quadrilateral, triangle, etc. Irregular polygons. In irregular polygons, all the sides are not equal and their sides may differ. Example: scalene triangle and rectangle. In square, all the sides are equal. Okay, all the sides are equal. This 2 lines that I add is used to represent equal sides. Okay, in equilateral triangle also all the sides are equal. In regular polygon also all the sides are equal, but in scalene triangle it can be like this or anything. It doesn't have equal sides. Okay, and in rectangle also 2 of the sides are equal but not all the sides. Okay, these two are equal and these two are equal, but all the sides are not equal. I hope you understand what are regular and irregular polygons. Parts of polygons. First is vertices and edges. So we will look at these with the help of a diagram. First we will take a triangle. Okay, so these are the vertices that I am highlighting. Wait a minute. These are the points that I have highlighted with the yellow color. And these are the edges that I have highlighted with the help of blue color. Okay, so these are vertices, and these are edges of a triangle. And then comes, let's check with the help of a rectangle or a quadrilateral, you can say anything. In here, these are the sides, these are the vertices, and these are the edges of a rectangle or any quadrilateral. Okay, I hope you understand till here. Now, what is angle sum property? Angle sum property is a property of polygons. Okay, according to the angle sum property of a polygon, in which the sum of the interior angles of a polygon is equal to n minus 2 whole 2 into 180 degree, where n is the number of sides of the polygon. Okay, so I will write it here down. N minus 2 into 180 degree. Okay, you have to learn this formula of angle sum property. If we take triangle for an example, okay, so it has three sides. Let's suppose this is of 3 centimeter, this is 4 centimeter, this is 5 centimeter. Okay, this let's name it A, B, C. Okay, so what is angle sum property says that n minus 2 into 180 degree. N minus 2 is equal to, there are three sides. There comes 3 minus 2 into 180 degree. 3 minus 2 is equal to 1 into 180 degree, that is 180 degree. All the angles here sums would be 180 degree. Okay, all the angles in the triangle, interior of the triangle, would have a sum of 180 degree. Okay, now we will go to, let's check about this formula with the help of a rectangle. Okay, so in a rectangle, or I will take a pentagon here. Let's name it A, B, C, D, E. Okay, A, B, C, D, E. Then comes n minus 2 into 180 degree, and here there are 5 lines and 5 sides, so 5 minus 2 into 180 degree. 5 minus 2 is 3 into 180 degree, and 180 degree into 3 is okay, so 180 degree into 3 is 540 degree. So we have checked it with the help of a pentagon, and now I will also check it with the help of a rectangle also, because it is a very important property and we have to learn this. Okay, so I will also check this with the help of a rectangle. Okay, rectangle. So now let's name it A, B, C, D. Okay, A, B, C, D. Now it has 4 line segments. So 4 minus 2 into 180 degree. And then comes 4 minus 2 into 180 degree is equal, so it is 360 degree. Okay, so let's go ahead. I hope this formula is clear. So n minus 2 into 180 degree is the whole formula to find angles and property of any polygon. Now comes about exterior angles. The sum of all exterior angles of any polygon is 360 degree. Wait a second. Okay, so any exterior angles of any polygon are 360 degree. So let's check it with the help of an example. Let's check it with the help of a triangle first. Obviously, first we will check with a triangle. This is one exterior angle, this is one exterior angle, and this is one exterior angle. Okay, these are the three exterior angles, and the sum of all these exterior angles will be 360. Okay, let's name it X, Y, and Z. Okay, so angle X plus angle Y plus angle Z will all wait a minute, I will name it Z, will always be 360 degree. Okay, and even if we check it with any polygon, the sum will always be 360 degree. Okay, and then first we will solve some questions about exterior angles and angles and property. So find x with the help of property of exterior angles. Okay, so here we have given x, so we have to find x. Okay, so this is 90 degree as it shows the 90 degree, and this will also be 90 degree. Why? Because it is a supplementary angle, and this is 90 degree, so this will also be 90 degree, because 180 degree minus 90 degree is 90 degree. And then comes, okay, so angles and property 90 we will write here. According to angles and property, 90 degree plus 70 degree plus x plus 60 degree is equal to 360 degree. Okay, we will write our angle exterior angles. I will write our EA, that is full form of EA is exterior angles, and then comes 90 degree plus 70 degree plus x plus 60 degree is equal to 360 degree. Okay, so 90 plus 70 plus 60 is 220 degree plus x is equal to 360 degree. Okay, and then we will take the x here. Okay, and this here. So wait a second. We will take x here and 220 degree here, and x will remain here only. Then comes x is equal to 360 degree minus 220 degree. Why? Because the plus here was a plus sign. We do not add plus sign here, but it indicates a plus sign. So when it goes here, it becomes minus 220 degree. Okay, so x is equal to 360 minus 220, that is 140 degree. So we will write here 140 degree. Okay, so voila, our question is fully solved. Find x with the help of angles and property. Here also we have to find x. This is they both are equal. You can see here they both are equal. Okay, so 70 degree and 60 degree angles and property you have to find with the help of angles and property. Okay, so this is a supplementary angle. So 180 minus 70 degree is 180 minus 70 degree is 110 degree. So this angle will be 110 degree. Wait a second, I will rub this up and write another space. So this angle will let's write it y and z. Y would be 70 degree, 180 degree minus 70 degree, that is 110 degree, and then Z is equal to, this is Z, okay, this is Z and this is Y. Okay, 180 minus 60 degrees, that is 120 degree. Okay, so this is Y is 110 degree and Z is 120 degree. This is 110 and this is 110 and this is 120 degree. And then comes X. Okay, so 110 plus 120 degree plus 30 degree plus X is equal to, okay, so angle sum property, what we have find that angle sum property, all the sides that are 1 2 3 4 5 sides are there, 1 2 3 4 5, okay, 5 sides are there. So 5, we have learned that 5 minus 2 into 180 degree and minus 2 is equal to 180 degree. So 5 minus 2 is 3 into 180 degree, that is 3 into 180 degree is 540 degree. Okay, 540 degree. And then comes is equal to 540 degree. Right, is equal to 540 degree. And then comes 110 into 120 plus 90 is equal to 320 degree plus 2x is equal to 540 degree. Okay, so 320 degree will go here, plus will become minus, so 2x is equal to 540 degree minus 320 degree, and then 2x is equal to 540 minus 320, that is 540 minus 320, that is 220 degree. Okay, so x is equal to 220 divided by 2, that is 110 degree. Okay, so this angle is 110 degree and this angle is also 110 degree. Voila, this question is also solved. Now we will go to next page. So what is quadrilateral? Our main chapter was on what are quadrilaterals. Okay, so quadrilaterals are polygons which are made up of 4 line segments. There are many types of polygons. They are parallelogram, many types of quadrilaterals. They are parallelogram, square, rectangle, rhombus and trapezium and kite. Okay, parallelogram, square, rectangle, rhombus, trapezium and kite. We will learn about this in a detail. So what is trapezium? It is a quadrilateral with a pair of parallel sides. You can see here, this is wait a second. These are parallel lines and these are also parallel lines. Okay, so this is parallel and this is parallel. So both these parallel lines, okay, this is parallel line segment, and this is also parallel line segment. Okay, that's why they are parallel line segments. Okay, that's why they are called trapezium. One pair of parallel lines, they have only one pair of parallel lines, are called trapezium. Kite is a quadrilateral whose 2 pair of adjacent sides are equal. Its 1 pair of opposite angles are equal. The diagonals bisect at 90 degree. You can see here, this is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. Wait a second, I will just write it here again. This is 90 degree, this is also 90 degree, this is also 90 degree, and this is also 90 degree. Okay, so this bisect each other at 90 degree. Okay, and these two are parallel, these two are parallel, and these two angles are also equal. Okay, so kite's 2 angles are equal, 2 pair of sides are equal, and all the diagonals bisect at 90 degree. Okay, so these are the properties of kite. Now we will go ahead to parallelogram. A parallelogram is a quadrilateral which opposite sides are parallel to each other. You can see here, both these sides, wait a second, all these sides are parallel to each other. Okay, this is parallel to this and this is parallel to this. Okay, Then comes square. Square is a quadrilateral whose all the sides are equal and all the angles are 90 degree. The diagonals bisect at 90 degree where opposite sides are parallel. Okay. So here you can see this angle is 90 degree, this angle is 90 degree, this angle is 90 degree, this angle is also 90 degree. All these sides are equal and all the diagonals are also equal. Okay. Now comes rectangle. A rectangle is a quadrilateral whose opposite sides are equal and parallel. Its all the angles are 90 degree. Diagonals bisect at 90 degree. You can see here this is 90 degree, this is 90 degree, this is 90 degree, and this is 90 degree. Okay, and this are parallel. This and this are also parallel and equal, and all the diagonals bisect at 90 degree. Okay. All the diagonals bisect at 90 degree. Now comes rhombus. Rhombus is a quadrilateral with equal sides. Opposite sides are parallel and the diagonals bisect at 90 degree. Here also the opposite sides are equal and all the angles are 90 degree and diagonals bisect at 90 degree. Find the perimeter of a parallelogram. We will do one question here. Find the parallelogram of perimeter. We have learned about parallelograms and all the sides are equal. Means opposite sides are equals and parallel to each other. Okay. So wait a second. I have written a different thing here. All the sides are parallel to each other. Opposite sides are parallel to each other and also are equal. So this is 14 centimeters. So this will also be 14 centimeter. And if this is 5 centimeter, then this will also be 5 centimeter. So we will add this up. 14 plus 5 plus 14 plus 5. Okay, so 14 plus 5 is 19 plus 14 is 33 plus 5 is 38. Okay, 38 centimeter is the total perimeter of the parallelogram. So answer hence 38 centimeter is the perimeter of this parallelogram. So we have done this question also. Now our chapter is over. Now we will do a small recap of this. So we will learn about the quadrilaterals and their properties. Okay, we will learn about parallelogram. I have a quadrilateral which each pair of opposite sides are parallel and opposite sides are equal, opposite angles are equal, diagonals bisect one another at 90 degree. Okay, rhombus, a parallelogram with sides of equal length, all the properties of parallelogram, and also diagonals are perpendicular to each other. Here also diagonals bisect at 90 degree. Rectangular parallelogram with a right angle, all the properties of parallelogram, each of the angle is a right angle, diagonals are equal. So do you know that rhombus and rectangle are also parallelogram? Okay, square is also parallelogram, but kite is not a parallelogram. Okay, all the squares are rectangle, but all the rectangles are not squares. This is also a fact. And then comes rhombus. All the properties of parallelogram and diagonals are perpendicular to each other. Square, a rectangle with sides of equal lengths, and all the properties of parallelogram, rhombus and rectangle. Kite, a quadrilateral with exactly two pairs of equal consecutive sides. Okay, the diagonals are perpendicular to one another. One of the diagonals bisect the other in the figure. And angle B is equal to angle D, but angle A isn't equal to angle C. Okay, so one pair of angles in kite is also equal. So I hope you learned something from this chapter. This chapter. Thanks to watch.